Next up, Blake from Foursquare.
Thanks a lot, Matt. Really happy to be here. Yeah, so today I'd like to talk about data-driven products at Foursquare. I'm Blake. I'm a data scientist there. So some of you probably already checked in, but I'm going to explain Foursquare just in case you haven't heard about it. Foursquare is an app that helps you explore your city and connect with friends. But it's also a rich API and platform for sharing location data and sharing this with many different partners and providers. So people use Foursquare for a variety of things. They check in, they share with friends, they discover new places, they're looking for tips, they're looking for deals, they want to keep track of their visits, they want to earn points and badges for going out and doing things in the real world. What most people don't know is that Foursquare generates a tremendous amount of data. So here's a little sort of snippet about what our stats are currently looking like. We have over 40 million registered users. We're aware of 55 million places all over the world. We've collected 4.5 billion check-ins, and we get about 6 million check-ins per day. So this is sort of what the data looks like. I've taken 3 months of these check-ins, around 500 million of them, and I've plotted them on a map as these simple dots of white light. You've probably seen this picture a million times before. You take anything, tweets or products or clicks, and you put them on a map, and they look something like this. What's really exciting about Foursquare is the fidelity of the location data that we're collecting. So this is zooming in on what New York City looks like. It's really quite staggering. You can see JFK down here in the corner. You can see all the airports lit up. You can see the bridges. You can see the Staten Island ferry line even. It's amazing what happens. All we're doing here is just plotting a few months of check-ins on a map, and yet all of these patterns of the city are starting to emerge. Foursquare thinks there's a tremendous amount of value in aggregating all this location data and providing services that no one else has provided before. Let's take a look at some more of this. Let's see. This is what Istanbul looks like. Again, you can see the ferries crossing the Bosphorus River. That's a famous bridge that I can't quite remember the name of. I probably should remember that. Oh, you know.
Istanbul Bridge.
The Istanbul Bridge. Oh, fantastic. Perfect. This is what Moscow looks like. You can see the famous circular ring road around the city. I really think that these things look more like organisms than they do like cities. And so, these are some pictures of check-ins, laid out on a map statically. There's an amazing amount of data in sort of the temporal dimension, too. So here I'm going to compare New York City on the left with Tokyo on the right. And I've taken over a year's worth of check-ins and put them on a map and lined them up by time of day. And so you can see now here it's about noon. People are at work, they're eating. And then, so the evening time's going to come around, and people are going to start going out to nightlife places. People are streaming home. It's very interesting in Tokyo, at least on Foursquare, it's a very transit-heavy culture. All the train stations are very popular and very connected. You can see that New York is actually the city that never sleeps. It pretty much doesn't die down at all. Here's people streaming in the morning into the major transit hubs and going to work. So this data, all this check-in data, represents sort of the aggregate mobility patterns of millions of people. And so what can we do with it? And that's what I want to talk about today, is these data-driven products. So personally, recently, I've been very obsessed with these sort of new kinds of contextual awareness products, things like Dark Sky, where it sends you a text message 10 minutes before it starts to rain, or like Google Now, where it pulls up your flight info when you get to the airport, or Passbook, or things like that. And so Foursquare, for the last year, has been working to build a product in this space. And so, we also at Foursquare use data to inform how we build products, but we also build a variety of products which are purely data-driven, that are just built from this exhaust, right? This data exhaust that's being created by millions of people carrying around this mobile device in their pocket that's creating all this rich data. And so I want to talk about this product that we've been working on that just shipped on Friday, so I'm really excited to be sharing with you guys. We're calling it contextual notifications. It's really just Foursquare notifications. It's the new Foursquare. But this is the first time I'm talking about it publicly, so this is the exclusive. There you go, Matt. The idea, right, is you walk into a venue, and without having to do anything, you get a notification like this on your phone. At Kanayama Sushi, people talk about the Superman roll, the tuna ribs, and surprisingly cheap omakase. You know, you don't have to check in, you don't have to do anything. This is just, you know, a great tip, push right to your phone because we know that you need it based on your context, right? So, and it works not only for venues, but for neighborhoods and cities as well. I implore you all to download Foursquare and try it right now. It is really awesome. So the idea is, you know, you touch down in an airplane in Paris, and you get a tip like, welcome to Paris, your friend Jeff Waugh has a list nearby, these are the places you need to check out. You know, walk into a neighborhood or a place, and we make sure that you don't miss the most important information about the place that you're at, but only if you're in unfamiliar territory. So you might be saying to yourself, like, oh my God, this sounds like incredibly complicated, like it's a very simple product, but like, how do you actually do that? And so I want to talk today about sort of the challenges to this product and sort of how we attack them by capturing a lot of data about people's mobility and sort of cleverly building machine learning algorithms to sort of tackle the key parts. So the first thing is accuracy, right? We need to know where you are with some degree of accuracy, and that's actually a hard problem. The second piece is sort of relevance and quality. We need to make sure that the recommendations we're giving you are of high quality and that they're relevant to you, that you'd be looking for a recommendation at this time anyway. And the third is battery life, which I'm not going to talk about too much today, but we spend a lot of time with our client engineers making sure this thing doesn't drain your battery. Less than 1% per hour is what it does. So the first problem, accuracy. How do we actually know what venue you're at? This is a hard problem. We sort of call it place matching. The idea is that given only this sort of noisy estimate of your location, can we actually map you to a venue which has a category and has all this context and all this, you know, social history and things like that? It's sort of a unique spatial search problem, and it's what powers, you know, the check-in button in Foursquare. The problem here is that a lot of times we don't really get an accurate signal from the GPS. Here's the reported horizontal accuracy by your phone. The issue really is that it takes a lot of power to get an accurate signal. It's hard to do indoors. And so the key is to be able to do well in a noisy environment. Again, you might be thinking, well, how hard could it be? You got a coordinate. You see if it's inside the venue. You know, you should know where all the venues are. It shouldn't be too bad. Okay, so here's all of the check-ins that have occurred at the Blind Tiger in the West Village. You can see that it's pretty simple to tell. Like, that's where it is. You know, the check-ins are pretty close to the center of the venue. We could easily distinguish it from, say, the check-ins at Washington Square Park or at the Spotted Pig or at, you know, these other venues. But when you start adding them all up, you realize that this problem quickly becomes intractable, right? Just looking at the check-ins for all these different venues is not enough to be able to tell precisely where they are. And luckily, though, you know, there's a variety of things we can do to sort of tackle this problem. The first is these spatiotemporal models. So what we've done is we've built spatial models of venues. So we've learned the way that your phone sees the world. Not a way that your satellite sees a map of the world, but the way your phone interprets the sensor signals around you and sees those venues. This is JFK, the Golden Gate Bridge, and the Blind Tiger. And another key aspect of this is because we're capturing this data exhaust, these 6 million check-ins per day, we know when certain places are popular and when they're not. And so you can see here, you know, this is a breakfast spot, a dinner spot, and a late night spot. You can see that if we look at their popularity over time, they're actually quite distinguished in sort of their temporal space, despite being, you know, spatially very close. Another tool that we have at our disposal is people are very predictable. We've seen that 73% of the time a person is going to a place that they've already been to, or 62% of the time they're going to a place that someone in their social network has been to before. So the idea here is that we're going to take all these signals, this popularity, these spatial models, these temporal models, these history models, and combine them into one machine learning predictor. And you have to do this in order to get accuracy. As you can see, all the individual methods sort of, you know, fall short of this sort of main goal of trying to figure out, you know, the venue you're at. So, you know, nearest neighbors in distance is just insufficient for this problem. You have to use spatial scores, personal history. You got to combine them all into one big model. Here we're using a random forest. And I just want to reiterate that the check-in search really is the key, right? You can't do machine learning with lat longs. It's just too hard. If you really want to understand how people are relating to places, you need to snap them to some contextually relevant place, like a venue, which has a category and which has history. So that brings me to sort of the next problem is relevance, right? We quickly found that if we just send you recommendations when you're just out and about, it really doesn't work. You're going to get bored really quickly. The idea is to sort of target these highly relevant contexts. Like, we don't want to ping you about the lunch spot that's underneath your office. If you're near your home or your work, you're probably very familiar with your surroundings. So the idea is we actually learn from your personal history where you are out of your element. And that's where we step in. This is built from this check-in exhaust and from all the data that's being created from your mobile device. And then the second part is, to the relevance and quality problem, is trying to understand sort of which tips are actionable. So this is like a very interesting sort of NLP problem. How can we sort of mine all of the tips and all the language that people are using on Foursquare to describe places to find the things that people are talking about the most, the statistically improbable phrases, people talk about pork buns, ramen, and cold spicy noodles at Momofuku, and also to figure out the sentiment of the tips, like are people talking positively about this place or negatively? And so here we've taken all this language created on Foursquare and combined it with the explicit signals, people saying whether they like the venue or not, and we've built sort of NLP models that can read text and extract these key recommendations and figure out their sentiment. Here's a nice picture of what our dashboard looks like, where we're dissecting the phrase, bad service, never let an associate go in the back because they'll never come back. So we can see that, the word come by itself might be, positive, but when it's, preceded by never, it's highly negative. It's just interesting to see these, little bits of how the machine sort of breaks down the language of the tweet. Another key aspect of what we're trying to do is we're trying to optimize real-world behavior. So a lot of people in the industry are tracking clickthroughs because that's a very reasonable way to measure sort of how well you're doing on the web. We've taken this sort of analogy and brought it to the real world where we actually measure walkthroughs. How often do we give a recommendation to someone and then they go out into the physical world and do the thing that we're talking about? And so for the first time, we can actually measure this. And so this is what we do. We run these large-scale, randomized control experiments where we try different things with different folks, and we see how well can we drive real-world behavior. Because we think that's actually the best way to align sort of our business with, our customers, right? People want to have great experiences in the real world. We want to help them do that. We want to help them connect with merchants. And so it really works out that we can have this sort of metric that we can actually optimize. For instance, we've noticed that with our recommendation product, Explore, 18% of people who see a result in Explore check in there within the first 3 days. Yeah, so I just wanted to reiterate that it's this data exhaust, which is the novel thing here. The fact that just by carrying around a simple device like this in your pocket, your phone can be aware of the context that you're in, the situation that you're in, and can be always looking out for the best way to give you the information that you need. That's what's, I think, very novel about sort of the time that we're living in right now. And, I'm talking about, Foursquare users today, and I'm talking about, tens of millions of these devices and phones. But these devices actually, there's more than, I think, 2 billion of them now in the world. They're all emitting the signal of latitudes and longitudes. And that is going to be the key to providing these sort of contextually relevant services, understanding not only sort of how the technology can help you, but how the technology can really fit into your daily life. Thanks so much.
Great. Thank you very much. So are you saying that what data are you capturing? So you're not just capturing data when I check in. Is that what you're saying? So you're capturing also. So when I use Foursquare, or by being a Foursquare user, I agree to having my lat and longitude information captured as well. Is that a? And I'm not going into like any privacy type thing. I'm just curious about how you get the.
Yeah, sure. So let's address privacy right away. We take privacy very seriously at Foursquare. Location data is a very personal and private source of your data. The way we think about it is we're not going to share your data with anybody without, we're just not going to share your data. But we are going to learn from your patterns, and we are going to try to, sort of listen to this stream of lat longs that's being created by your device, so that we can give you the best information from your friends or from the Foursquare community.
Great. Questions? One question over there. Actually, take this one first.
I can understand if now a lot of people are using Foursquare, it's easier to get those information and give people advice. But in the beginning, when there is not so many people using Foursquare, the information probably is not accurate when you give people advice only based on 2 or 3 users' information. So I really want to understand at the beginning of Foursquare how you grow up from very few users to a lot of users.
Great. And what was your name and company, please?
My name is Hong Duan, and I'm from Bloomberg. Sorry.
Yeah, that's a great question. I actually think that Foursquare has an amazing story. They started off as sort of like a fun game that you played to collect badges and earn mayorships. And then only in the last couple of years did they realize that they're just sitting on this mountain of data that's incredibly valuable. And so, yeah, I think that you needed to have that bootstrap, right? The data at scale is so much more valuable than the data that we had in the beginning. But people were interested in using the service because of other things, And so I think that was one of sort of the cleverest things that Foursquare did was bootstrap based on these fun single-player experiences into something that has a tremendous amount of value when you combine, lots of the data from lots of different people.
Could you, to build on the question, could you do this now with, I don't know, the factuals and there's a few companies with location information? Could you start a Foursquare-like recommendation system without that bootstrapping phase these days?
I think that there's a lot of sort of generic solutions to place recommendation that you can build with sort of any reasonable directory, but it really lacks the sort of I think it lacks sort of the special sauce that Foursquare can bring to the table because it is tapped into this this live data that's being created at such a massive scale. I didn't really talk about it too much today, but we really believe that sort of users vote with their feet, right? They don't vote with words on a website where they may or may not have been there, but just simply by watching how users move around the real world, whether or not they go back to a place, which other places do they go to, how do they follow their friends. I think that's where the real value is in building a place recommendation engine. And I think it's very hard to do that without tapping into all the data that's being generated by a mobile phone.
Well, what's amazing is that it seems to be incredibly effective, right? You said 18% was the rate of people checking in after an Explore. I mean, I guess it's a self-selected pool because there's people actually using Explore, but
yeah.
Still, it's huge.
Yeah, it's very interesting to see how we can sort of influence behavior, and the people who are using our recommendation engine seem to really be getting a lot of value out of it. Okay, great. All right, then the lady over there, and we'll just take one, and we're starting to run a little tight on time, and Blake will be around, after 8 for the drinking part.
Hi, I'm Sydney Beveridge with Social Explorer and an occasional Foursquare user. And I was just curious, it's interesting to hear about this, but about with the sort of tips and suggestions that people put up, is there a way, do you guys kind of control for or bring into account sort of vendors that might be trying to pump up their own ratings, or do you trust certain users more as being more reliable users, perhaps, than others who are just kind of occasional? Is that kind of built in at all, or considered? Sure. So, like every other social media product, we are constantly fighting a war on spam. And we do our best to try to identify people who are using our system to, promote their own stuff in some way that we don't like.
I think that, again, we have a real benefit in the way that we're set up because we're relying on data which is like highly personalized and very hard to fake, right? It's really hard to fake a user with a like verified GPS trail going to a business like and having these real friends on a social network. You know, like that's just it's a very hard thing to fake at the moment. Although I'm upset to say that because that's probably like Hillary's probably gonna write a Twitter bot that like goes on Foursquare and has all these fake social networks, and it's gonna be really hard for me to detect. But I do think for now it's hard to fake.
Okay, great. So that's all the time we have. But again, so Blake will be around for questions. So thanks a lot.
Thank you, Matt.
Thanks.